Another use of differentials is to express derivative formulas. And a lot of times, if you're an engineering major or perhaps a math major, you'll take at some point a course in differential equations, and differentials are just another way of we can use them to express derivatives formulas. Now we want to be a little bit careful because lots of times people refer to derivatives as differentials. They're not exactly the same. Remember, a differential is a derivative, basically a derivative multiplied by an increment. And so we want to be careful that we don't confuse the two. All right, but they are used to express formula. So let's take a look at this. If y is a function of x, all right, then dy, we can think of dy as the derivative of y with respect to x times dx, or df we could think of as the derivative of f times dx, and they would be the same thing. Dy and df would be the very same thing. Both of them would be the derivative of this function times dx. So what we can do lots of times, we can use a derivative formula, and then we'll start with this example. The derivative with respect to x of x squared is, of course, 2x using the power rule. And what we can do is we can talk about a differential of x squared. And the differential of x squared is going to be the derivative of x squared with respect to x times dx. And of course, that would be 2x, and the derivative of x squared is 2x dx. So this differential d of x squared is 2x dx. Let's take a look at a few other formulas that we can write this way. All right, the derivative of sine is cosine. So we can talk about the differential of sine, and the differential of sine is the derivative of sine times dx, the derivative of sine of x with respect to x times dx, and that's going to be, excuse me, the derivative of sine is cosine, so that'll be cosine of x times dx. Remember, this dx represents a derivative, an increment, so we have the derivative times an increment here, and so we would have d sine of x is equal to cosine of x dx. And that's another way. This would be the differential form of this derivative formula. Okay, let's take a look at another one. We know that the derivative of the product of f and g is the derivative of f times g plus f times the derivative of g. So the differential of f times g is going to be the derivative with respect to x of f times g times dx. And now if we write that out, that derivative is, of course, f prime of x times g of x plus f of x times g prime of x. And we multiply that by dx, distributing the dx through this quantity. We would have f prime of x, I should say, times dx times g of x. I can multiply those in any order, of course, plus f of x times g prime of x, times dx. And notice f prime of x times dx is df. And so we have df times g of x, all right, plus f of x times dg. The derivative of g times dx would be dg. So we have df times g, or g times df times g plus f times dg. Okay, one more, and this is one that's commonly used, all right, is with the chain rule. We often express formulas in terms of the chain rule so that we have, excuse me, um, if in the chain rule, if we have the derivative with respect to x of f of u of x, that's f prime, the derivative of the outside function, evaluated at u of x times the derivative of the inside function, then the derivative with respect to the differential, I should say, of f of u of x is the derivative with respect to x of f of u of x times dx. And that would be f prime of u of x times u prime of x dx, which is going to be f prime of u du. And so the differential of the f of u of x is f prime of u du. And lots of times we'll see formulas expressed this way. All right, for example, the derivative or the differential of the natural log of u is equal to 1 over u du. The derivative, the differential of cosine of u is negative sine of u du, and so forth. Okay, so, and this is the differential formula. You don't see differential formula a really lot until you differential formula, differential notation. You don't see differential notation a lot until you get into differential equations. That's where it really crops up.